Hi. So today we are going to looking at a problem where we discuss about Zener diode and its design related question. So in this question we are asked to find VL, VR, IZ and PZ, and it's given that the Zener is of rated of VZ is equal to 10 volt and PZ, which means the maximum power dissipated is 30 milliwatts in the Zener diode, which means VZ into IZ should be uh, less than 30 milliwatts, and we have a input voltage of 16 volt and the series resistors of 1 kilo ohm, right? So first of all we can find VL. So we are asked to find VL. So in order to find VL, what you need, this is the VL, right? This is also point. These are the same point. So first thing first, we have to check whether our Zener diode is it in a reverse biased state, which means a typical Zener diode have a Kara reverse Kara, somewhat like this, right? So this is the knee point, the reverse breakdown point. So this should be in the volt. This is the voltage axis, this is the current axis, right? So it should be in a region of this, right? It should be in this region in order to get our required operation. So in order to check whether it's in the right region of operation, we can redo the circuit just like this. Instead of we just leave the Zener diode like that and complete the others part like this. And this is 16 volt, this is 1 kilo ohm, and this is 1.2 kilo ohm, right? So this will be the VL, this will be VL, right? This will be VL. So what will be VL? We just apply the voltage divider rule, which means 16 into 1.2 divided by 1.2 plus 1. This is just the voltage division, so it will be the VL, right? So what will be this value? This value is 8.73 volt. We got 8.73 volt. So it's actually less than the reverse breakdown voltage, right? Actually the Zener is rated for VZ of 10 volt, so it should be at least operated in the 10 volt, right, in this region. So otherwise it won't be in an on state. So we can just look into the actual Kara given here. So this is the Kara. So in this Kara you can see that in the Z axis, in the voltage axis, it's 8.73 is somewhere here, but we have to, in order to operate in a Zener mode or it's a reverse breakdown voltage, it will at least be 10 volt, right? So actually our Zener diode is in off state, so there is not any regulation or it's not acting like a shunt regulator. Now we can easily say that definitely if the diode is not conducting, IZ will be equal to 0, right? Okay, actually, then what we have to find? Then what we have to find? mm, VR. VR. What will be VR? VR will be V input minus what? VL. How can be it's calculated? This is the VR and this is the two terminal. This is the plus terminal. This is the minus terminal. So we can just calculate using VR is equal to VI minus VL. It's actually what? VI is 16 minus 8.73 volt. It will be what? 7.27 volt, right? So we got VR is equal to 7.27 volt. Then what we have to find the IZ? We know IZ is 0 because the diode is in off state. And what about the PZ? If diode is non conducting, then IZ is 0. What is P? What is the power? Iz into Vz. We have Iz is equal to 0 and Vz is 10 volt. Then it's definitely 0. So there is no power dissipation in the zener because it's not in a complete reverse bias, or it's not in an open state, right, on state. Then what is the next part? So with this resistor R, we can say that this Zener diode cannot be in an on state, right? It cannot be operated in a regulator. It's not cannot act as a regulator, right? So for that, what we have to do? We have to change the this part, means the resistor, series resistor R. So we have to modify the series resistor R. So this is our second part. So in the second part we are asked to say that it's uh, change the load resistor RL is equal to 3 kilo ohm. So we are changing the load resistor, not the series resistor. We are changing the load resistor. So then we again find what the VL. Again, what will be VL? VL can be calculated using our voltage divider equation once again, right? We already draw the diagram, which we just omit Zener diode and calculate the VL, right? So 16 into instead of 3 kilo ohm, 1.2 kilo ohm, we have 3 kilo ohm divided by uh, what 1 plus 3, 1 plus 3 means 4, so it will be 12 volt, right? It is 12 volt. Now we can say that the according to the Kara, the Z voltage is actually above the Zener breakdown voltage. So it's in complete reverse bias, and it's in the on state. Diode is the Zener is acting like Zener is now it's in the regulating mode. Shunt, can now act as a shunt regulator. So now what we have to find? We have to find uh, VR. What is VR? In order to find VR, what we have to do? We have to just find the difference between the two potential. One end is 16 volt, the other end will be VL. VL is already it's not 12 volt, it will be 10 volt because the zener will regulate the 12 volt into 10 volt, right? If the zener is in the on state, on mode, then what will do, it's the potential across it will be always the sun will be the zener voltage. Now we can find the VR by using the equation Vi minus Vz, right? So what is Vi? 16 volt. VZ is 10 volt, not 12 volt. Why? Because zener will be in a regulating mode, which will be regulating the voltage into 10 volt. Because that's why zeners are useful, right? That's why we are using zeners. So 16 minus 10, which is 6 volt, right? We got 6 volt. Then what we have to find? The IZ. IZ. Okay. So by examining this circuit, we can say uh, sum of uh, input current be II1, we can call this current as II1, and is divided into IZ and IL, right? So we can write like this: I1 is equal to IZ plus IL, right? So actually I can write uh, the formula for IL. Actually, what is the load voltage? VL by R, right? What is VL? VL is we have got as 12 volt. What is RL? RL we choose as 3 kilo. So 3 kilo. So it will be 12 by 3, 4 milliamps, right? 4 milliamps. Actually, we load voltage is not 12, it's actually 10, right? This is the voltage without the zener, right? So if you place Zener, the VL should be the 10, the actual load voltage should be 10, right? So what we can do is, it's 10 by 3 kilo ohm, then it will be 3.33 milliamps, right? Actually, I made a mistake here, please check that. And next we can actually find I1, which means the input current, which is equal to IR, the current through the resistor. Actually, what is the voltage across the resistor? Voltage across the resistor is 6 volt by the resistance. What is the resistance? It's 1 kilo ohm, so it's 6 milliamps. So what will be IZ? IZ will be I1 minus IR. What is I1? I1 is 6 milliamps minus 3.33. So what will be the answer? The answer will be 2.67 milliamps. So this is the IZ. Then again we have to find what is the power PZ. We have to find the power PZ, which is equal to VZ into IZ. We already know VZ is 10 volt, and what is IZ? IZ is, we already got 2.67 milliamps. So it will be around 26.7 milliwatts, actually, which is less than our rated voltage. So it is, we already given that PZ max is 30 milliwatts, right? What we got is PZ is equal to 26.7 milliwatts. So our Zener diode is in safe range of operation. So that's how we proceed with. We have to first check whether our diode is in the correct bias. So in order to that, just omit the Zener diode and proceed with the voltage divider rule, and we will get the voltage across that. Then we got it at 12 volt. Then definitely the Zener diode will act as a regulator. Then replace the Zener diode there. Then definitely VL should be the Zener voltage. Zener voltage is 10 volt. Then we will proceed like just applying the basic rules of circuit analysis, right? So that's how we complete the solution. Thank you.